All right, hey guys, we are going to be starting Module 13 and 14 today. I apologize for my voice because I'm sick, but I will do the best that I can, so sorry in advance. So the notes for this video are going to be in Schoology, so you can download those there. You also want your calculator and a notebook today. So our learning goal for today as we start Module 13 is we are going to model exponential growth and then analyze residuals. Okay, now first thing I want you to do before we even get started, I want you to pause the video. What is a residual? Do you remember? We talked about residuals in a different module. I don't remember what number. Back when we were working with linear growth. So can you go back and find out what a residual is? And then we'll kind of talk about it throughout this lesson. All right, so here's our first problem. We have, well, first of all, it says bivariate data that show a relationship resembling exponential growth or decay can be modeled by this function. We know that already. And A represents the initial value and B represents the growth factor. So I have a table here, and if I wanted to make a scatter plot of the data, I want to know, does it appear to be exponential growth or decay, or is it linear? Okay, so first thing you might kind of think is like, okay, let me just check if it's linear. Is it going up by the same amount every time? All right, well, if I did that, it appears to be, this looks like up 55 and then up 45, up 70 something. Okay, so it is clearly not linear. Okay, I want you to go ahead and graph those points in Notability. And then what do you think? Is it exponential growth or decay? I should have talked about this too, but this is showing the aquarium visitors, the time since 2010, and then how many visitors in thousands. So in 2010, that would be year zero, there's 250,000. In 2011, that would be 305,000. All right, so if I take a look at this, I graph the data, and it appears to be exponential growth. Okay, so if you kind of look at it, it is not perfect exponential growth because it is a scatter plot. Okay, so I've got some points like right here that are not on my curve, but it appears to be exponential growth. It's increasing from left to right. Now, what if I asked you to predict how many visitors there will be in the year 2018? Okay, so basically think right now 2010 is the 0 year, so 8 years from there. How many visitors do you think there will be? Just make a prediction and write it down. This is called, when we are making a prediction like that, extrapolating. Okay, so could you extrapolate how many visitors are in 2018? So take your guess. All right, so since we did say that this was exponential growth, we want to figure out, well, what is the growth rate or the growth factor? Well, to do that, we know what we usually do. We usually divide, like if I was looking at this table, I would do 305 divided by 250. Okay, if I do 305 divided by 250, I end up with 1.22. I'm going to go just to 2 decimal places. Okay, now I'm going to do that for the next one. So if I did the next one, it would be 350 divided by 305. Okay, kind of hard to write this in that little table, but see if you guys can fit it too. So then I would do from here to here, 350 divided by 305. And then I would do the next one, which would be 420 divided by 350, right? To go from here, from 350 to 420. Then I would do 515 divided by 420 and 610 divided by 515. Okay, I want you to pause the video and fill in all of those numbers, please. All right, if you do that, here's what you should get: about 1.15, about 1.20, 1.23, and 1.18. All right, so what do you notice about the relationships between the successive V values? So that's the visitor values, right? What do you notice about them? It looks like these are all pretty close. Okay, and we would expect that to be pretty close because it's the multiplier, right? It should be, if this is exponential growth, it made a pretty good curve on my graph. It wasn't perfect, but I would expect these to all be pretty close. So if I wanted to kind of find, you know, what would be a good B for this, a good exponential growth, I might actually find the average of these. Okay, so to find the average, I would just type, add those up. So 1, 2, 3, 4, 5, and then divide by 5. If I add those up and divide by 5, it's about 1.20. So if I was going to choose a b for this exponential model, I would probably choose about b equals 1.2. Now again, it's just a model. It's not going to be perfect, but that's what I would do. And then I forgot to answer a question. See, how do your findings in part B relate to your graph in part A? It's the multiplier to go from one to the next. Okay, so it's growing about 1.2 times bigger every time. What is the value of A? Well, that value does not change. That's the starting value. So that's 250. So if I was going to write my exponential growth model for this, I would say V of t. So to find the visitors after a certain amount of time, my starting amount is 250. And then my growth is, or my multiplier is 1.20 to the t power. Now, just a couple quick things for you guys to notice that the A value, this was perfect. This B value, this was an estimate. All right, so if you recall from when we were working with linear models earlier this year, a residual is actually kind of like the distance between, or the amount between the actual and expected. So like if this was the point on my scatter plot right here, I just kind of did in black, and I'm predicting if I drew up my line of best fit, I would think it would have been there. So let's just say this was for after like 20 years or something. I would expect it to be here, but it was about here. The residual is like how far away that is. So to find a residual, you take the actual amount, that would be here. Let's just say it was 500. I'm just making up numbers. And then minus the expected amount. Maybe right here, I expected it to be 400. So I would do 500 minus 400. My residual would be 100. Okay, now you might want to write that down in your notes, in your notebook. If I were you, I'd write this down. So to find a residual, it's the actual amount minus the expected or predicted value that you thought it was going to be based on your equation or based on your graph. Again, here's my model that I thought was my line of best fit. So that helps me to make predictions. Again, I would predict it should have been here at 20 years when it was actually right here. Same thing here. Maybe at 10 years, I predicted it was here. I mean, my prediction is it would be right here on this line of best fit, but in actuality, it was right there. So to find the residual, I could just kind of draw that in. I would subtract those two. All right, I would like you guys to read through this top paragraph right here. Just read it to yourself real quick, and then I will kind of talk about it. Okay, so when we were drawing your lines of best fit, we were able to measure like how good it was. Like we wanted the very best line of fit. If you guys remember when we went into decimals, we tried to get the very best one. To do that, we found something called the sum of the squared residuals for each model. Okay, the one with the least sum of squared residuals is the one that is the best, that best fits the data. Okay, so I'll show you kind of what that means. So we have Megan. She made a model. Here was her model that she came up with. Okay, so this is what she's predicting our table will follow. She said, okay, I know my starting value. She used her multiplier as 1.22 and then to the t here. Okay, so she just used 2 data points. She just used the first 2 and she said, I'm going with that, 1.22. She didn't find the average like we did. Okay, so what we're going to try to do is figure out, using her rule, can you fill in what she would predict after 1 year, 2 years, 3 years, 4 years, and 5 years? Okay, so obviously after the 0 year, it would still be 250. Okay, so for the first year, okay, the actual amount on the scatter plot is 305. We're going to kind of compare that to the predicted. So to find the predicted, here's what you'll do. You'll do 250 times 1.22 to the first year. Okay, so grab your calculator and type that in. All right, well, we get 305, which kind of makes sense because that's what she used those first 2 points. Now to find the second year, it should be 350. That's what it is on the graph, but we're going to see what she predicted with her model. This is her predicted model. So I'm going to do 250 times 1.22 to the second power. Okay, please type that in. Okay, looks like I should get 372.10 if you type that in. Okay, I want you to do for year 3, 4, and 5. Pause the video and please do those. Okay, so your next number should have been about 453.962, if you check that one out. Your next one, I'm going to have to write kind of small, but 553.83364. And then your last one should be about 675.67740 something. Okay, I don't have the exact number, but up to there. All right, that actually should have been a 04 at the end. Okay. All right, so now here's what I want you to do next, and I apologize, all of this takes a long time. I want you to find the residual between each amount. So column B is the actual amounts, column C is the predicted. To find the residual, you want to do the actual minus the predicted. Okay, so the actual minus the predicted. Okay, so if I do the first one, so I'm going to actually do column B minus column C. I get 0 here. I also get 0 here. Okay, so if I do row 4, if I do 350 minus 372.10, it looks like I end up with negative 22.10. Okay, I want you guys to find the residuals for the next 3. All right, so it should be something around there. Okay, so now the next thing that you are going to do is find the square of each of the residuals. So basically you're going to take column D and you're going to square it. Okay, so I'm going to take 0 squared. Well, I know that's a 0, so that one's pretty easy. Then I'm going to do 0 squared again, I get 0. If I do negative 22.10 squared, so that means basically 22.10 times 22.10, I know it's going to turn into a positive, I get 488.41. Okay, now I want you to square the next 3. So again, you're squaring these numbers that are right there. Make sure you at least try one of these to make sure you're doing it right. So I get 1153.417444, 1508.051596, 4313.473688, something about like that. All right, your next step is to find the sum of the squared residuals. So that means you are going to add all of these numbers right here up in yellow. Okay, now I know you guys could add those, so I'm just going to add it for you. Sorry, and I get 7463.35272. That is the sum of the squared residuals. Okay, so that was Megan's model. We want to see, and remember, the best model is the one with the least sum of the squared residuals. So this was hers. Okay, so we're going to compare her model now to somebody else's model. All right, so if you go to the next slide, or if you just kind of follow along now, we're going to use Austin's model, which is basically what we got. So we're going to use our model. So this is our predicted model for our line, for our curve of best fit. Since this is an exponential, I should stop saying line. It's a curve since we're doing exponential growth. So we're going to try to fill in ours now. So do you remember how to do all of these? Okay, could you find the residual? Can you fill in the predicted column? And can you get this number as well? And then we're going to see which one is better. So I want you guys to go ahead and try to fill in this table. You can get with a partner if they're at the same spot as you. Fill this in and then push play when you're ready to check the answers. All right, so I filled in the table. You guys can go ahead and see. And if you look at the sum of the squared residuals for Austin's model, or for our model, it's 426. Now that number is lower than on the screen before than Megan's model. So this one is a better prediction. Okay, so this one has a smaller sum of squared residuals, so that one's better. Now, did you guys notice, I forgot to kind of talk about this, how some of these are positive and some of these were negative? All that means is maybe, well, if this was a line, if they're above, that's positive. If they're like kind of below the line, that is kind of a negative. So it says, is the sum of residuals or the sum of the squared residuals a better measure of the goodness of fit? We're going to say that the sum of the squared residuals because they are all positive. Okay, that is a little bit easier to measure. So that's why we use this instead of this, because some are above the line, some are below the line. And that shouldn't really make, that doesn't make the line better or worse, or the curve better or worse. If it's above or below the same distance, that shouldn't matter. So that's why we use this, because it is positive. Okay, so we decided that Austin's model, or our model, is a little bit better. Okay, so here's the equation. So now, can you predict how many visitors that there will be in 2018 using our equation? So I'm going to do 250 times 1.20, and I'm going to use to the 8th power because the year 0 was 2010, and it was 8 years from then. So I'm going to do 1.20 to the 8th power, and then times 250. So my prediction is about 1,074.95, or about 1,075 visitors. So how close were you with your prediction? All right, so I just want to show you the actual graphs of the curves for each of our equations. Obviously, you guys could do these in decimals, but here's what they look like. The actual points are plotted in red, and I know they're kind of hard to see, but like here's one, here's one, here's one. Well, obviously, I think that was one. Kind of hard to see. And then we have Megan's curve in green here. Okay, so you can see kind of her curve. Okay, and then we have Austin's, and that was our equation too, is in blue. So if you're looking at it, which one looks like a better curve of best fit? I would say the blue one, it's definitely closer to the red points. So this is a better model for my exponential function. All right, so hopefully that made sense. We'll still be working on this a little bit more tomorrow. So now I want you to go ahead and try the homework. This is posted in Schoology. I also will have the answers posted, but please actually try it so you know if you're doing these right. If you need help, you can ask the teacher or ask anybody in your group. So try this homework, and then please check your answers as well.